One area where Matlab is particularly useful is in the computer implementation of linear algebra problems. This is because Matlab has exceptional capabilities for handling arrays of numbers, making it a useful tool for many scientific and engineering applications. We're going to start off with multiplying vectors, followed with a Matlab example. Then we're going to multiply a matrix and a vector, followed with a Matlab example. And finally, our last example is we're going to multiply matrices, again followed with a Matlab example. So let's begin by multiplying a vector. And we know that a vector is basically a one-dimensional array consisting of numbers. Here, Matlab allows you to create column vectors or row vectors. First, we're going to multiply these two vectors. This one has 2 rows and 1 column. This is a row vector consisting of 1 row and 2 columns, and this notation is by convention. What we should note is that the inside numbers here between these two vectors, this row vector and this column vector, should be the same. So the net result when we finish multiplying this vector is a 1-by-1 scalar. So here, when you multiply this number or these set of vectors, is that you say 3 times 3 plus 4 times 4. 3 times 3 plus 4 times 4, and the result yields 25. So here we are at the command window of Matlab. We're going to start off with a column vector A. So we'll start off with a left bracket, 3, then a semicolon which separates the elements into rows, 4. So here we have a column vector A. We'll take this column vector A and convert it into a row vector B, and we do this by saying B equals to A apostrophe. The apostrophe stands for transpose, which converts a column vector and a row vector and vice versa. We also use it for matrices. So here we have a row vector, and now we'll take the row vector B multiplied by the column vector A, and we should get 25, which is the same result as before, as shown here. Now we're going to multiply a matrix and a vector. So here we have a column vector of 2 by 1, and we're going to multiply it by a 2 by 2 vector, and what we should have a net result is a column vector of 2 rows and 1 column, just like what we started off with. So to multiply matrices, we take 3 times 3 plus 4 times 4 for the first row, then 5 times 3 plus 5 times 4. This is shown here, 3 times 3 plus 4 times 4. Now taking the second row, we have 5 times 3 plus 5 times 4. Now doing the multiplication operations here, we have for the first row 9 plus 16, and for the second row we have 15 plus 20. Then adding this, we have for the first row 25, and then the second row is 35. So here we are back in the command window of Matlab. As before, we'll define a vector A, 3 semicolon 4. Again, the semicolon separates it into rows, so now we have a column vector. Now we have a vector matrix B, 2 by 2, which is basically 3 and 4. That's our first row. And our second row will be 5, 5, and so therefore you have a matrix of 3 and 4 in the first row, and 5 and 5 for the second row. Then we multiply B times A, and we should get 25 and 35, which is the same result as before. Now we're going to multiply matrices. Here we have a 2 by 2 matrix and another 2 by 2, and the resulting should be a 2 by 2 as governed by this index here and here. So our outer indices governs our net result of 2 by 2, and that the inside indices should match. So we're going to take this first row and this second column and multiply it. So that's just 3 times 3 plus 4 times 4. Then trying to find this element is a result of multiplying this row by this first column here. So this is 3 times 1 plus 4 times 2. Similarly, we'll take the second row multiplied by this second column here, so that's 5 times 3 plus 5 times 4. And then finally we'll take this second row multiplied by this first column, and that's 5 times 1 plus 5 times 2. Doing the operation of addition, we result into 11 for this location here. 3 times 3 is plus 4 times 4 is 25. 5 plus 10 is 15. 15 plus 20 is 35. Okay, back here at the command window, we have a matrix A of 1 and 3 with a semicolon, which again separates it into rows. So what we have in the first row is 1 and 3, and then 2 and 4. So that's our matrix A. For matrix B, we have 3 and 4 separated, semicolon separating the rows, and then 5 and 5. And so there's our B matrix, and then B times A is equal to the same result we had before. So that concludes our example on how we used Matlab to multiply a matrix and a vector, two vectors, and two matrices.